The automotive world just experienced an earthquake that nobody anticipated. In Sweden's quiet countryside, a small team of engineers has unleashed something that's making the electric vehicle titans nervous. A power revolution tucked inside an impossibly small package. The EV promise that started to crack. Remember when electric vehicles were supposed to change everything? They promised environmental salvation, performance superiority, and a clean break from fossil fuels. Tesla led this charge with impressive machines that made combustion engines look like relics. Governments worldwide embraced the vision. Europe announced plans to ban internal combustion by 2035. California set aggressive timelines. China poured billions into EV infrastructure. Major manufacturers pledged allegiance to battery power, promising a cleaner future. But beneath the hype, cracks began to appear in the electric dream. Range anxiety persisted despite technological advances. Most EVs still couldn't match traditional cars on long journeys, especially in cold weather or when using climate control. Fast charging helped, but waiting 30 minutes for 80% charge wasn't comparable to a 5-minute gas station stop. Then there's the uncomfortable truth about batteries. Building one Tesla requires significant amounts of lithium, cobalt, nickel, and other materials obtained through environmentally questionable mining operations. Reports connecting cobalt extraction to exploitative labor practices raised ethical concerns. Lithium mining consumes massive water resources in already drought-prone regions. Weight became another issue. Electric vehicles typically outweigh comparable gas models by hundreds of kilograms, causing increased tire wear and road damage. Perhaps most significantly for enthusiasts, something intangible was missing. Despite impressive acceleration figures, many electric vehicles felt similar digital, sanitized experiences lacking the mechanical soul that makes driving special. They became sophisticated appliances rather than emotional machines. Enter Koenigsegg, the rule breaker. While the automotive world chased Tesla's formula, one small company in Ängelholm, Sweden played by different rules. Koenigsegg wasn't interested in market share or conformity. They pursued innovation with singular focus. For years, they operated in near silence, occasionally releasing hypercars that defied physics. The Agera RS shattered speed records. The Regera eliminated the traditional gearbox entirely. The Jesko redefined track capabilities. But no one predicted what would happen next. The moment everything changed in 2025, without fanfare or marketing campaigns, Koenigsegg revealed two revolutionary technologies that sent shockwaves through the industry. A synthetic-fueled combustion engine that challenged pollution assumptions, and an electric motor so advanced it made current EV technology look primitive by comparison. The dark matter motor, weighing less than 40 kilograms lighter than a checked suitcase, generates 800 horsepower and 1,250 newton-meters of torque. For context, Tesla's Model S Plaid needs multiple larger motors to achieve similar output. What makes this motor extraordinary isn't just its compact size, it's the engineering approach. Koenigsegg developed what they call a axial flux design, combining radial and axial flux technologies into a 6-phase architecture. This allows more consistent power delivery with significantly better thermal management. Christian von Koenigsegg demonstrated the motor's compact dimensions by holding it in his arms during the reveal, approximately the size of a carry-on backpack, yet delivering more torque than most full-size SUV drivetrains. Unlike complex multi-motor setups requiring sophisticated software to manage torque distribution, the dark matter uses a single unit with real-time response connected directly to Koenigsegg's proprietary torque converter and inverter. Fewer components means fewer potential failures and virtually no wasted energy. But Koenigsegg didn't stop there. They paired this revolutionary motor with an equally impressive internal combustion engine, a turbocharged power plant designed specifically for synthetic e-fuels, producing over 1,500 horsepower with near-zero net emissions. This isn't a modified existing engine. It's built completely in-house with a new block, valve system, and turbo architecture engineered from the ground up to integrate perfectly with hybrid electric technology while running on carbon-neutral synthetic fuel. When combined, these technologies produce a staggering 2,300 horsepower and 2,750 newton-meters of torque in the production-ready updated Gemera, a 4-seater Grand Tourer with practical amenities that outperforms dedicated hypercars while avoiding the limitations of heavy battery packs. The Koenigsegg philosophy: engineering without compromise. What makes Koenigsegg's achievements so difficult to replicate isn't just technical innovation, it's their fundamental approach to engineering. Unlike mass-market manufacturers constrained by production scale requirements, Koenigsegg controls every aspect of development. From carbon fiber layup to 3D printed titanium components, they build in-house what others outsource. Their free-valve technology replaces traditional camshafts with pneumatic, hydraulic, and electronic actuators, giving each valve independent real-time control. This allows unprecedented flexibility in engine management, something major manufacturers are still experimenting with, while Koenigsegg has been implementing it for years. The Regera's direct drive system eliminates the traditional gearbox entirely, using a hydraulic coupling that connects engine directly to wheels with electric motor assistance. This creates seamless acceleration without gear shifts or power interruptions. Their light-speed transmission redefines shifting capabilities, allowing jumps between non-sequential gears instantly, something conventional transmissions can't accomplish. This philosophy extends throughout their vehicles. They don't just buy carbon fiber, they weave it in-house with precise control over patterns and resins. They don't order titanium components, they print them with their own 3D printers. Every decision serves performance, efficiency, or control. If it doesn't improve the car, it doesn't go in. Why Tesla can't simply copy this approach? Tesla's business model demands scale, producing hundreds of thousands or millions of vehicles. This requires standardized parts, global supply chains, and cost per unit considerations. Koenigsegg isn't constrained by these factors. They pursue ultimate engineering without compromise, building dozens rather than millions of cars annually. Their handcrafted approach allows explorations impossible at mass production scale. The dark matter motor exemplifies this difference. While traditional electric motors use three-phase systems, Koenigsegg developed a six-phase axial flux design combining two distinct magnetic field arrangements into one compact unit. This creates more efficient torque delivery with reduced heat generation. Because the motor is so compact, it opens packaging possibilities unavailable to conventional EV designs. It works with Koenigsegg's custom torque converter and inverter to minimize energy loss, and doesn't require additional motors for torque vectoring since it can manage distribution internally. Their synthetic fuel engine addresses another EV limitation: the environmental impact of battery production. By designing an engine specifically for carbon-neutral synthetic fuels created from captured CO2 and renewable energy, they achieve near-zero emissions without depending on problematic battery materials. This approach preserves the emotional qualities that make driving special: sound, vibration, responsiveness, while eliminating environmental drawbacks. Together, these technologies form a system challenging fundamental assumptions about electric vehicle design. Do we need massive batteries? Must performance vehicles be heavy? Are range anxiety and charging delays inevitable? Koenigsegg answers no to all these questions, offering an alternative blending the best aspects of combustion and electric without inheriting either's disadvantages. The industry response: the automotive world now watches Koenigsegg with fascination and concern. If their approach proves superior, delivering better real-world performance, range, sustainability, and driving enjoyment, then the big battery strategy starts looking questionable. Tesla's competitive advantage hinges on battery technology and software integration. If synthetic fuels gain momentum and lightweight hybrid systems outperform heavy battery configurations, Musk's roadmap suddenly appears limited. Following Koenigsegg's announcement, Musk posted cryptically, "Physics is the ultimate arbiter." Industry insiders interpreted this multiple ways. Some saw defiance, others uncertainty. Reports suggest internal discussions at Tesla questioning how a boutique manufacturer achieved greater torque density and thermal efficiency than a global electric vehicle leader. Some engineers argued Koenigsegg's technology couldn't scale, while others warned that scaling might become irrelevant if the paradigm shifts. Christian von Koenigsegg's strategy is refreshingly straightforward: prioritize engineering excellence over market share. Each project balances performance, sustainability, and driving pleasure without compromise. The provocative question emerging from this development is simple: if Koenigsegg can build a four-seater Grand Tourer that outperforms dedicated hypercars while using carbon-neutral fuel and compact electric propulsion, what excuse do other manufacturers have for building heavy, uninspiring vehicles in the name of sustainability? The road ahead: a split path. Koenigsegg hasn't ended electric vehicles, but they've challenged their inevitability. For years, the narrative seemed clear: batteries would replace combustion entirely, with software defining the automotive future. Now, multiple viable paths have emerged. One continues pursuing larger batteries and increased range. The other asks how much can be achieved with less weight, complexity, and supply chain vulnerability, potentially delivering more enjoyment, beauty, and balance. The next few years will reveal whether Tesla doubles down on their existing strategy or adapts to this new paradigm pioneered by a small Swedish company that quietly rewrote the engineering rulebook. The future of automotive performance might belong to those willing to question conventional wisdom rather than follow it. Did this video blow your mind? Let us know in the comments below. Don't forget to subscribe to our channel and share this with friends who love automotive innovation. Hit that notification bell so you never miss our latest breakdowns of industry-changing technology.